could mute your mic. Anyways, so about Microsoft Cloud. So whatever you see under IT now, like anything, website hosting, IoT, machine learning, uh, particular services, anything that is under IT, everything, all of those services have been ported into this particular thing called as cloud. So instead of having your own hardware and infrastructure at your company's local data center, a local data center that is owned by your company and managed by your own company. Instead of that, what this new thing about cloud computing is that you use someone else's infrastructure and resources to reduce your own costs, and also the management part is relieved out of you. There is a particular thing called as shared responsibility. Like, for example, I want something in some cloud, say for example Microsoft Cloud. I want a virtual machine, or I want something else, anything. So that particular hardware that will host this machine will not be managed by me. So there are particular benefits of cloud computing, as well as there are some drawbacks of cloud computing. So we'll start by introduction of what is cloud computing. So the main thing about Microsoft Azure is there are a hell lot of services. There are many services which are clubbed together under the domain, or the company Microsoft, and they have given it a name, Microsoft Azure. Yeah, so this particular Microsoft cloud, that is Azure, this gives us the ability to manage, build and deploy applications across a global network. So if I want my application, say for example, I want to host a website, and I want it in a particular region. Like for example, say that I have a service that I provide to people, and my user base, that is the people who I provide service to, are from UK. So there are a particular set of rules that has to be followed by us, the service providers, with respect to the user's data. If I have the data of the users whom I am servicing from UK, then I need to follow the policies of the UK government with respect to their data handling and security. So everything, these things can be done with the help of Azure. So you won't need to manage all these things, because Azure will already govern all those things within that particular area. Say for example, there's a country which wants that whatever that the data of my citizens should stay in my country itself. It should not go out. So in that case, what you can do is, instead of buying a whole data center and create buying so many resources and infrastructure, you can just rent a machine or whatever you want to do on Microsoft Cloud, which has a data center in UK. And Microsoft is a private and public platform. So about private and public, when I as a company, say for example Contoso, that is a typical name which Microsoft use for every its examples when it teaches people. Anyways, so about private and public, yeah. So when Contoso wants to create something, deploy some service, so it needs some PC, it needs some networking, and it needs some resources so that it can host that service in a particular computer, which can service all of those users from outside who want to take a service. For example, I'm hosting a service of, say, video compression, and that such a thing needs a lot of computational power. So I need a machine. I might need a server rack itself, and I need to give my users the ability to use my machine. That is through networking. So basically, networking is nothing but connecting to anyone, right? We say the word internet. So internet and intranet. Intranet means within our own private network. For example, say for example, my own college. So when I compare my college to the outside world, so the networks within my college are called intranet, whereas the networks of uh, outside the college, if I network with someone outside the college, that is called as internet outside. So basically, the whole internet needs something. For example, there is a user in India who wants to connect to a service in UK. So there is this whole internet thing, which is a very vast network of devices, and your request goes through all these nodes and finally reaches your server that is in UK, and finally comes back to you and you get your compressed video. So all those things can be done in Azure. And how Azure does this is through virtualization. So instead of allotting every single machine to people, we virtualize hardware. So there is this particular thing called as hypervisor. Say for example, I have a server, a big server rack, and within that I have say for example 25 cores, uh, about 150 GB RAM, and about say 20 to 30 TB of hard disk space, and some SSD. Anyways, so what I want is I want a particular virtual machine, say for example of 2 GB RAM, 2 cores, and 100 GB hard disk. That is the ROM. So I don't need to create a particular machine of that thing. What I can do is I can just install a particular software called as hypervisor on my server rack. So what it will do, it will partition that hardware virtually. So I have that whole hardware, and I create a virtual partition on that hardware and say, okay, this is allotted to a particular virtual machine, and on that hardware, my OS is installed. So that is virtualization. Again, hypervisors are of two types. One is called a bare metal hypervisor, that is the one installed on the server rack, and there is a tier 2 hypervisor, which is installed on your virtual on your own OS on your PC. You has anyone used VirtualBox or Hyper-V or VMware here?
Yes, yes.
Yeah, so those are tier 2 hypervisors. So Microsoft provides you all these services through virtualization. So they have all this hardware and they virtualize particular slots in those hardware and allot them to you as virtual machines or containers or anything. A virtual machine is no different from a physical computer like a laptop, smartphone, or server. So, like I said, there is a particular hardware that's allotted to you, and there is a OS installed on it. It might not be a physical computer, but it does the same work of the physical computer. That is why it is called the virtual machine. It has a processor, memory, disk to store your files, and can connect to the internet if needed. So everything that is there in your own machine, when virtualized on on a hypervisor, is called a virtual machine. So each virtual machine can interact independently. So it's a machine in itself. The machine does not know that I am a virtual machine. It knows that I am a OS operating system in itself. I am complete and an independent system in itself. So that it can connect to the internet and do anything that you want with it. So there are basically four types of virtualizations. The first is desktop virtualization, which allows the centralized server to provide managed uh, individual, individualized desktops. So the first is desktop virtualization. Desktop virtualization means that you virtualize a desktop, basically a PC. You virtualize that, and that is called a virtual machine. The second is network virtualization. So there is something called as SDNs, software defined networks. So when we do networking, you guys might have seen Ethernets in our labs in college. Ethernet cables going here and there and into some switch and then connecting to all your PCs.
Yes.
So that is the physical part of networking. So about virtual networking is nothing but you're connecting things virtually with the help of software defined networks. So basically, if you say, for example, create a subnet or you create a network and say, okay, I want this network to connect to this, then a virtual path is connected and your packets can travel through, which normally is shut down by a software, also called as firewall. You all, you guys have, every one of you has a firewall in your computer and your phone and other devices as well. So in this big infrastructure of Azure, about software defined networks is that everything is blocked at first, and whatever access you want, that is opened for you, and that is opened via this software defined networks, which is nothing but a second type of virtualization that is called as network virtualization. The third is software virtualization. This basically separates application from hardware and the operating system. So has anyone heard of Docker?
Yes.
Yeah, so software virtualization, it separates application from the hardware and the operating system. So when you know if you know about containers, okay, that might go, I'll come on it later, like that will go into some a little more higher concept. So let's stay on the basics first. The fourth is storage virtualization. So similarly, there is this storage virtualization, like I have again say 1000 TBs of uh, hardware devices or hardware type of storage devices. I'm sorry, storage type of hardware devices. Yeah. So when that is virtualized and allotted to you on cloud. Has anyone heard of Amazon S3 buckets or Google buckets? If not, all of you do have a Google account, right? A Gmail account. So you have a Google Drive which has 15 GB storage. So that is nothing but the four type of virtualization. That is storage virtualization. Yeah. So the next is so this is how the hypervisor thing and the operating system works. First is the material, the server rack itself, and there is the hypervisor installed on it. The hypervisor partitions this hardware into certain slots and then installs your operating system on it. So this is an example of just one operating system on the whole server rack, and this is an example of multiple different operating systems. So regardless of your operating system, your hypervisor will work. It only needs an image called as a ISO file .iso, that is your operating system image file or the disk file, which can be installed on the particular hardware or allotted to you. So in this example, you can see one is Windows, one is Linux, and other one is a custom image. So Azure uses virtualization technology and deploys it at a scale in data centers around the world. So Azure does not only have a particular, 5 or 10 data centers. It has a lot of data centers throughout the world. So if you want to, for example, say for example, you have some users in UK, some in the US, some in Africa, and some in the Middle East. But you don't have any users in China, Japan, basically the eastern part of Asia. So if you don't have any users there, what you can do is you can create particular, hotspots where, say for example, there are within these countries also there are multiple data centers. So this is just a spot, like for example, India. Within India, there are three data centers: one in the central, one in western, then one in north. also one in south, four actually. So within that area also, like for example West India, say for example Central India, there is not only one data center. There are multiple data centers in that central, Indian area. We'll come into those concepts. They are called as regions, and under regions are data center. So basically, there's a particular area which is called as, say for example, Central India. Within that, there are particular regions or zones, and each zone is a data center. So there is a region, and there is a data center in it. So for example, there is, in Central India, there are, say for example, three regions. So, and each region is, it has a lot of space between them. So they are not very close, but at the same moment not very far. So in case there is some disaster, natural disaster, if say for example light goes off somewhere, there is a natural disaster somewhere, anything could happen to the data center. So what you can do is, you can replicate all of your resources into uh, the most nearby, the nearest data center. Also, why we need these data centers is, for example, I am hosting, my user base is in UK, and I am hosting currently a website in India. So what I'm seeing is that the latency of my website is quite high because my server is in India, whereas my users are in UK. So to decrease that latency, what we can do is we can shift our virtual machine or whatever service we are taking here to that particular region within UK that is nearest to our user base. So that is how we'll achieve the best or the least latency. Each data center has many racks filled with physical servers, and each server contains a hypervisor to run multiple machines. So within one data center, there is not just one server or two server. A data center is very big, and it has a hell lot of machines. So I'll just show you a image. Just a second. So there are rooms like these, and there are very big rooms like this. This is just one of the room and one of the sections of that room. So what you see in this image, you see those layers. Each layer is a little server, a server rack, horizontally placed and connected through all those Ethernet and fiber optic cables. And here you can see an image of how big a data center is. And another thing about these data centers is that they have their own energy source. So these are not very close to, cities and other commercial areas, and they are a little bit towards the rural side, but not too far. So they can have their own energy source. For example, windmills and water turbines can help them create energy. So that is how Azure also cuts down on its costs. Anyways, next we'll go to a server runs a hypervisor with several virtual machines that are running at the same time. So there's a big rack. So about rack, there is a big rack, and within that rack are servers. So you see these little rectangle boxes within this big rack. So the whole thing with many slots, horizontal slots to put inside servers are called as racks. And we'll come into why I'm telling you that there are these racks, because there is something called as availability sets which utilizes these racks. So for example, this particular rack say goes off for some reason. So what you can do is whatever you had in this rack, you can replicate that into another rack. So your service does not have a high downtime, and you can you can deliver whatever service you want, whatever you're hosting to your users. So about virtual machine, a virtual machine is no different from other physical computers like a laptop, smartphone or server. It has processor, memory, again, then storage, networking, connecting to the internet, etc. While components that make up a computer called hardware are physical and tangible. Virtual machines are often thought of as virtual machines or software defined computers in physical servers, which exist only as code. Yeah, so when we are talking about virtual machines, say for example, I have this PC right now, which is an Intel iCore, uh, an Intel Core i7 with a G4 GTX GPU, 1650, 16 GB RAM, and 1 TB SSD. So on this, for example, I have say two virtual machines. One is Linux and one is Windows. So that virtual machine itself, what I have on my PC is nothing but a piece of code, which is running on my own operating system. So when we talk about a difference about physical and virtual machines, the physical computer itself, this physical computer which I have here, is to be managed, kept clean, and I have to provide power and all those things to this machine. Basically, I am responsible for this hardware. Now, when I have purchased it, so when we're talking about a virtual machine, the hardware, the cloud company providing us that hardware is responsible for that hardware. We are not responsible to whatever happens to that hardware. Say this machine, this virtual machine will, for example, after using it for 8 9 years, this will slow down a lot, become laggy. Then I'll have to buy a new computer. But that is not the case with virtual machines. If that hardware, degrades, then the cloud company buys new hardware and throws this off, or does whatever waste management with this, recycling and all those things. So basically, I am not responsible to what is happening to the hardware, and the cloud company is responsible for the hardware. That is the main thing about virtual machines. So this is about the operating system basics. So in cloud, there is the server, basically a big piece of hardware materials, cores, networking interface cards, storage devices, disks, and SSDs, GPUs, etc. So on that there is my host OS, basically the hardware, then my OS. The host OS, basically you can say it as uh, a piece of code to control that hardware, that big hardware on that server. And then there is the hypervisor, which will create those virtual slots of hardware devices so that your guest OS, basically Windows, Linux, anything can be virtualized on that. Then there will be binary files and libraries which your OS uses and uh, does whatever you want, create apps, host services, whatever. This is just illustration of how things work. When you can see here, there is a virtual machine or virtualization server, then there's a physical server, and then there's a shared storage. So actually there is not a very big storage that is shared among all these. So in small machines this might be the case, but when we are talking about a huge servers, many servers, so these storage devices are connected to each other via networking, and a shared pool of storage is created, and this is accessed by these machines. And within this there are again virtual slots that are given to you, so you can use your virtual machines. Networking switch provides connectivity to all the servers. In each server runs the special software called as fabric controller. Each fabric controller connects to another software known as orchestrator. So when we're talking about networking, how things connect to each other, there is a particular thing called as fabric controller, which will connect us to something called as a piece of software called as orchestrator. These are new terms within cloud computing. So basically there's a network switch, then there are all of your servers, and these are then connected to something called as a fabric controller. So what this fabric controller does, it connects you to an orchestrator, which is responsible for managing everything within Azure. So there are particular nodes within data centers. There are particular little nodes which are assigned to certain places. So within these orchestrator and fabric controllers come in. There is a particular, say for example, server room. It is divided into many parts, and those parts are called as nodes. So each node connecting and communicating with each other, and the whole Azure infrastructure system is done via these fabric controllers and orchestrators. So again, Azure just does not only connect you with its own infrastructure, but also connects you to the internet and other infrastructures of other clouds and other companies. So you can also have multi clouds. For example, there is particular service within Azure that is connecting to AWS, a service in AWS, or a service in Google Cloud, or some other service somewhere else. So these are connected to Azure via something called as a web API orchestrator, which you can see here. So basically the orchestrator, this packages everything that is needed and chooses the best track of servers which can handle your request. So what I said, there is say for example, to imagine things in a limited perspective, you have a server room, you want to execute some request, and the server room is divided into particular parts called as nodes. So within these nodes there are many servers and racks. So each node is there is how do I explain this? All right, yeah. So each node is checked for its availability, like how much hardware is used, how much is remaining, how much it can handle, etc. So the balance is equal. So this orchestrator, it talks to the lower level things. Again, there is this web API orchestrator, then there is this normal orchestrator, and finally the fabric controller, which is connected to the servers. So based on availability, this web API finally understands which node is to be selected for our request. And that is how whatever request we are asking Azure to do, for example, create a virtual machine, build this network for me, do my machine learning task, etc., etc. That is how it is done. So these are some of the services within Azure which are very popular. Azure Arc. So basically, what it does is it can unify your on-premise. Basically, what is on-premise? It is called as a private cloud. My say my company, we want to do something, so we need that hardware itself to host something and do some computation, so we can provide someone some service. So when I purchase that hardware and manage that hardware myself within my company, that is called as on-premise or a private cloud, because it is only available to me, my company. That is why it is my own private property. It is the private property of the company itself. When we are talking about public cloud, then there is Microsoft Azure or AWS or GCP. So anyone in the world can access these resources by paying to Azure and AWS and GCP and other cloud providers. That is called as a public cloud, because the all of the public, everyone within the world can access it and avail the services with paying a little cost, paying whatever the cost is of that service. Then there are Azure container apps. So when we talk about containers, I think it will better if I explain you with some illustrations. Um, So when we are talking about containers, first of all, if we say of a normal virtual machines, so they go this way. First of all, there is my hardware, then there is uh, my operating system, and within that operating system might be my app 1, app. This is the case in a normal operating system. So when we are talking about containers and virtual machines, so what a virtual machine does is that it virtualizes the hardware so that we can install the operating system on that particular hardware slot. So virtualizing hardware will create as a virtual machine. But when we virtualize the OS itself, it creates a container. So now this virtualizing an OS may uh, sound very confusing to you. So what we have here is, say there is that hardware which we have. Then there is the kernel. Basically, it is an part of the OS operating system. So what this does is, just a second. Yeah. So we have this hardware. Then there is the operating system installed on the hardware, and on that operating system, basically on my this Windows PC, then I have something called as Docker. This is one of the containerization apps that is available in the market, which is very popular. So what this does is Docker will virtualize this operating system itself. So normally what happens when we create a virtual machine is that there is this hardware OS, this hardware OS and the app. This is the normal Windows PC which we have. So when we're talking about a virtual machine, there will be another layer between here which is called as hypervisor. Which will come here. Yes, there is the hardware. On that there is the hypervisor, which creates a particular slot for an operating system. Say for example this much space, and on that is my application. So this is the case in the virtual machine. So what this does is when creating a virtual machine, the OS itself is installed on that hardware. So the kernel, this kernel which does the computational part of things, connecting hardware to the software. This is created from scratch when we are creating a virtual machine. But when we are using Docker, this is the case in a virtual machine, basically hardware, hypervisor, new kernel creation, OS installation, within that hosting of our application. But when we are using a service like Docker, what it does is I have my hardware, then I install my OS on it. Basically, if we take my computer in an example of my own computer, I have hardware. On that I have my operating system, Windows 11. Then on that I have installed something as called as Docker. So what this Docker client does is it virtualizes the OS itself. So for example, when I want to create a machine, a new virtual machine within Docker, so what it will do is instead of using creating a new kernel for whatever reason I want it for example, a virtual machine, a Linux virtual machine. So when I create a new virtual machine for Linux, at that time the kernel for Linux will be created again. That is why creating virtual machines and setting up virtual machines takes so much time. But when you're talking about containers, what it does is it accesses the same kernel which is already available. That is why it is fast. So on Docker, let me just erase all this. Yes, there is my hardware. There is my hardware. Then the kernel was, there is the kernel, there is my OS, and then there is Docker. So what this will do is now that, say for example, I want to create a Linux container on a Windows machine that is here, say Ubuntu. So what this will do here is this Ubuntu machines, whatever process I want to do with this, these threads will be accessing the same kernel of my Windows machine, which I can also show you here. If you know, it will be very fast, a very fast process. If anyone has anyone done this before? Has anyone created a Ubuntu server or any Linux server on VirtualBox or Hyper-V VMware?
Yes.
Yes, yes.
This is Docker Hub, basically the container. There is a repository online. So a repository is nothing but a storage system where all these machines and this uh, how do I say this? Yeah, the container, the image of the container. So if I simply do this docker pull Ubuntu. Okay, I need to start Docker first. So this is the Docker software on my own PC, Docker desktop. Once I start this and I can pull that image. Image is nothing but the OS file. So the OS file for Ubuntu, which is very compacted, compressed to work on Docker, will be pulled here. So here the Docker daemon is starting. Within Linux, we call processes as daemons, daemons. Instead of calling it a thread or process, we called it daemons. So yeah, Docker has started. Now I can do Docker pull Ubuntu. Now the normal image for Docker for Ubuntu is about, I think, about 3 GB. So but here you can see that the image is just 30 MBs. Why is this so? Because Docker here is only working on a command line interface on this terminal itself. So here I can just run this. And I can just pull out the CLI, the command line interface. And here you can see ls, and my Ubuntu machine is ready to work. cd/home directory test. So the directory for test is created, and if I want to create some sort of file, text.txt, hello world. So now I have the folder text test and the file text.txt. I can simply print this again, text.txt. So there is hello world inside that. So the basically you can see how fast it was. This is because it is not creating the kernel itself and only accessing the available kernel within my PC. So anyways, I'll stop this. Yeah, so that is a the basics of containers, how containers work. So now on this Ubuntu container, I may have some application which works. Say there is a website, and what this basically does is it creates threads within my own PC. So when I'm trying to host this website, so whatever work this Ubuntu container wants to do, it will create a particular thread within my own Windows uh, operating system. And these threads are so properly and amazingly scheduled so that your PC does not, it won't even notice the difference. So basically, when you see that I was running Docker, my PC did not even get as slow as when we run a virtual machine. When we run a virtual machine and we are doing something on our own host PC, then our PC starts to lag a lot. But when we talk about Docker, it is not doing anything but only creating a thread within my all of those threads available in my PC itself. So that is how this is the whole operating system. So this is divided into many threads, many threads. So what it does is, what it will do when it wants to do some task, it will just go here and add a single thread here. That's it. So that is why containers are very popular nowadays. So one of the services is your container apps. Then many other services. If I keep on illustrating things, then run out of time and other things that we need to talk about. Then machine learning, AI, cognitive services is nothing but OCR, optical character recognition. Basically, I given an image, whatever is written in it is written to me as text, or some other actuation is done. Then quickly deploy AI solutions for business processes. DevOps. So DevOps is another thing that is very trending in market right now. So basically, what DevOps does is, I have some particular code, and there is a cycle of the whole dev and ops operations. So DevOps is a full form for development and operations. So previously, what used to be is that there were two different departments. One was a developer department within a company, and there was an operational department in a company. So there was a part who only developed things and pushed this on to quality assurance and all those people, which again then when goes to security, a security check is done, and finally then this thing is goes to the code which is to be deployed goes to the operations department. Now, for example, I have many users, and a single PC cannot even handle that many users. You might have heard of DOS attacks, denial of service attacks. So basically, if a PC is loaded with a lot of requests, then it will start responding because it has a particular RAM and a particular processor which can handle only limited things. So if we need to, serve more people, then we need to scale our system up. Scaling is nothing but creating, increasing the capability of our application to serve people. For example, right now my application can serve 1,000 people at the same time. So if I scale this up, then for example, I could serve 5,000 people. I could serve 10,000 people. Based on my requirement, I can scale up things. So to scale up things, what we need to do is we need to create more virtual servers running the same application and connected to each other. So that is how there are so many big companies. For example, Netflix, Google, uh, Microsoft. These websites are being accessed by people almost the whole day, and even millions and billions of people are accessing it daily. So why are they not having system crashes and all? Because they are dynamically scaling up and scaling down. Whatever their requirement is at that particular time, they increase their infrastructure and management automatically on cloud, and whenever their requirement is low, they decrease that to cut on their costs. So Azure DevOps is one thing which you just deploy your code here. It will do it will check it will check your codes for errors, security issues. Like for example, there is a secret key that you have in your code and you forgot to hide it somehow. So what it will do is it will not deploy it and stop the process there itself and notify you about that. So if everything is passed, then finally it goes on to the operational department within the Azure DevOps. So there are servers which do this stuff and they deploy your application automatically. Then there are other services such as Azure Kubernetes service. So what I talked about these containers. So these containers are very small things. So a container at most, for example, I say an Ubuntu container. So the resources the Ubuntu container uses is very less. Hence, it can only serve a very small amount of people. So when I want to create a big application with containers, then I need to manage many containers, and that is done through this uh, container orchestrator, which is also called as Kubernetes. This is very you guys might have heard of this Kubernetes, K8, Docker, because these are currently highly in trend in the IT market. Then cognitive search, bot services, etc. There are many more services within the certain fields. There is hybrid cloud and multi cloud. I have some apps on my I have hosted some apps on my particular hardware that I have on my own company. It's private data center, and I have some apps on Azure. So somehow or the other, I want those apps to connect somewhere for data exchange. So that can be done again through hybrid and multi-cloud things. I just, for example, I want virtual machines from Azure. I want to host websites. And do other things on AWS, and so I want to do machine learning on GCP, Google Cloud. That is also possible because these clouds have internal connections to each other, which can help you do that. And these are services which help you do that. Then there is IoT. Again, Internet of Things is also blooming right now. So all of that, microcontrollers and things, Raspberry Pi, all those small processors and microcontrollers can be connected to Azure, and then data search can be done. BigQuery, you can find it for anomalies. For example, some controller detected something wrong in some machine, so you want that controller to do something on your industry or notify you whatever you want. It can be done from IoT, uh, from Azure IoT Central and Azure IoT Edge. Then again there are containers and compute resources, virtual machines and containers. And there is this particular thing called as Azure Functions. So about Azure Functions, for example, say I have a website and I want my website to do some computation only when an image is uploaded, right? So the website is hosted, but I don't want it to always keep a machine running in my background and cost me money. So what we could do is we can host the website, then we can connect that website to this particular thing called as Azure Functions. So we'll come on to Azure Functions later when I'll come about this shared responsibility model and how uh, how much you are responsible of whatever service you're using. What is SaaS, PaaS, and IaaS, infrastructure as service, platform as a service, and software as a service. So we'll come on to this later. Azure Functions is something very important. This is also called as serverless compute. If you want to run any code without having a virtual machine or anything else, even a container, you can run that code using Azure functions. So we'll come on to Azure shared responsibility model. So when you are hiring some resources within Azure to use for something, at that time there are particular responsibilities that you and Azure holds for that for those services. So when we are talking about I think I should first talk about SaaS, PaaS, and IaaS. Yeah. Okay. Just a minute. We'll come here. So whatever I'm showing you, all those things are being referred from here, learn.microsoft.com, and this particular examination called as AC 900. And also, I am certified of this. I've certified this exam. I'm certified. So there is this particular thing called as shared responsibility model. So first we'll come at private, public, and hybrid cloud. So private cloud is nothing but basically I doing some things at my own physical data center of owned by my own company, managed by my own company. That is private cloud. Then there is public cloud when I only uh, the public cloud is built, controlled, and maintained by a third party cloud provider. So Microsoft Azure, AWS, and Google Cloud are public clouds because the hardware and management, network management, all those things are done by the cloud provider themselves, and we are just using their services. It is called public because anyone can purchase those services and access those resources. And about a hybrid cloud, when we have a certain application or a particular service that utilizes both of these architectures, which is private and public cloud, then it is called a hybrid cloud. So when we talk about the differences of public, private, and hybrid clouds, so when we are talking about a public cloud, we only pay for what we use. No capital expenditures to scale up. Say for example, when I have my own private cloud and I don't have Microsoft Azure and these other clouds, so if I want to scale up my service, for example, right now my service is able to handle only 1000 users. If I want to increase that capacity to 5000, I will have to buy a new machine and somehow integrate that machine into my current application somehow. So that additional cost of buying a machine that is taken by me within when I am using a private cloud, when I am managing and purchasing things of whatever servers and things I need to use. When it comes to public cloud, what we can do is we can simply rent another virtual machine. We'll only be paying off the virtual machine and not of buying the new hardware itself, because buying new hardware and managing all that is up to Azure. That is not up to us. We only pay for what we use. When we talk about hybrid cloud, it provides us with the most flexibility. So I can decide which application needs to be on my premise. There are, for example, for safety, for example, I'm a bank right now. Okay, so I cannot have my user base passwords and these things stored on a public cloud. It's very risky. So things like this, secret keys and passwords, these might be used on cloud, but it is very much advised to have that on your own private cloud, because then you are wholly responsible for the data center, the external the external security of data center, and also the cyber security of the data center. Hence it's, this architecture of hybrid cloud, this will provide me the most flexibility. I can decide what application I want on on my own data center, and what are things that I want to host on the public cloud. Then there are applications that can be provisioned and deprovisioned. So on the public cloud, what to simply for example, I have hosted a website. I want to remove that website for some time. So that itself to do on a public cloud is very easy. You just simply click on the resource and click delete. That's done. So when we do this thing on a private cloud, then many problems occur. For example, there are certain applications. If and things are interconnected to each other, and if I turn down the application, I basically if I turn something off, then it will affect the other things as well on a private cloud. Because data, what reason is that that data is not collocated to other organizations' data. When you are on a public cloud, to connect and share resources is very easy, whereas on a private cloud, you need to manage all those things from the ground level itself. So it is very complex to uh, quickly remove and again start a service. To start a new service on a private cloud, it needs a very basically too much of preparation and testing. After that, something is released. But when on public cloud, this can be deployed within seconds. Organizations determine where to run their applications. So basically, for example, say there is a particular thing, Microsoft and Azure have a tie-up on one particular service, right? So if I want to do that on a public cloud, I want to shut down that service. It is very easy. I simply select service and delete. But to do that on a private cloud, I need the other organization's approval as well, because this in some way will also uh, affect their resource in some way. Because for example, there's an application running which is constantly asking some network for something, and if some network totally now stops decides to stop talk to that other machine there, so that other machine may return some error message or some other thing. That is why right now a particular thing called as loosely coupled architecture is being used. Also, you might have heard of something called as microservices. Has anyone heard this term before, microservices? Hello.
Yes. No.
Has any? Okay. So basically, microservices is uh, you have a particular service, a big application, which is cut down to certain parts of an application, and to connect them to each other, you're using a loose architecture. So basically, if one particular section of the app decides not to talk to the other section of the app, then the other section of the app will not be affected in any way. That is called as a micro service architecture. You, instead of having everything connected to each other, and if one thing fails, the whole application fails, you create it in such a way that if anything fails, it does not affect the other thing. That is called as microservices and a loosely coupled architecture, which is again very trending in current IT sectors, in the current IT sector. Then organizations only pay for what they use. On public cloud, I only pay for what I use, because I don't own the hardware, I don't manage the hardware, I simply use the hardware. And I just rent, I basically just pay for renting it for that particular time. Hardware must be purchased for startup and maintenance. So whatever I want to do on a private cloud, I need to purchase that hardware to start and provision something. And the maintenance takes cost as well, because there is a whole maintenance team itself that you need to hire, and again managing those people as well. So when you're talking about public cloud, the IT maintenance team decreases a lot, Actually, in some cases, it is the maintenance team is totally removed because there is no more hardware now, and no one needs to keep that hardware in check. Are these things working properly? Is this thing doing this? Is this thing doing that? You can simply have an administrator which was there previously too, and just add him a little bit of checking things within cloud, which is easier for him. He can just do that with simple a bunch of a few clicks. Then organization control security compliance or legal requirements. So within hybrid cloud, basically the organization itself, uh, they can decide, they're free to decide what things they control and what things they don't. I can have particular things privately, I can have particular things in the public cloud, which won't affect me and might affect me according to whatever I want. So there is the most flexibility is there within that hybrid cloud architecture. Organizations don't have complete control over resources and security. Yeah. So as I mentioned, if I am a bank and I want that, say for example, my data should be in encrypted in this server, and on this server, no one should use uh, this server's racks. The basically that rack what on which I have my data. No one should be able to rent a server from that rack. So within public cloud, that is not possible because you only pay for what you use, right? So if you provision the whole rack, then you might use the whole rack. But if you say I want a server, excuse me, I want a particular virtual machine, and I don't want other thing connected to this. This is not how this works. So within private cloud, this is very easy. So, the hybrid architecture within Azure, what it allows you is that you can also rent whole servers and server rooms themselves. You can create a private cloud within a public cloud in Microsoft Azure. So for example, there are 10 server rooms. Then you can go up to the Azure team, and you can tell them, okay, I want this room to be rented only by me. No one else should use this, and these are the security measures that I want you guys to follow. So then that thing which was previously a public cloud is now allotted you as a private cloud. That is again a hybrid architecture in some way, but that comes under the private cloud. Organizations are responsible for hardware maintenance and updates. So when it's a private cloud, at that time, I am responsible for the hardware, maintaining and updating it. But when it is a public cloud, at that time, the cloud vendor is responsible for all this. So I'm sorry. Actually, the example I just gave a few moments ago, that was wrong. That was wrong actually, because if I rent a whole server room within Azure, still I am not responsible for uh, hardware maintenance and updates. That is again managed by Azure. And if Azure does something wrong here and there, then my important data, say for example, I am a company which does finances on all those things by for banks or some other companies, then the data I'm talking about is very sensitive data. And if somehow or the other someone messes this in some way, then I am in trouble. So when we're talking about public cloud, organizations do not have complete control over resources and security. Even if you hire a whole server room within Azure, still the hardware and maintaining and updating it is up to Azure. Then multi-cloud, I have some particular application which uses different clouds. As I said, storage is used from uh, Google Cloud, then machine learning is done in AWS, and then computation part is done in Azure. This is called as a multi-cloud thing. Then Azure Arc. Azure Arc is a set of technologies that helps manage your cloud environment. So what basically Azure Arc can do, it can manage your environment, your cloud environment, regardless of it being a public cloud or private cloud or a hybrid configuration. or even a multi-cloud environment. So basically there is this particular software called as Azure Arc. It can help you manage all of these clouds on that particular software itself. So instead of logging into GCP and doing this, logging into AWS and doing this, logging into Azure and doing this, you can just log into Azure Arc and access all those things. Then Azure VMware solution, I have my private cloud which I have created using VMware solutions. Basically, they are hypervisors and networking services. You have installed all these and integrated your whole system on your own private cloud, and now you want the, you have seen that people are moving to public cloud, and their costs are reducing because the management and buying infrastructure, managing infrastructure, all those costs are removed right now. So you're thinking that okay, this might help me drop down my costs and my profits will increase. So you want to go into a hybrid, either an hybrid or either a public or on a public cloud architecture. So you can use Azure VMware solution, which can migrate your whole VMware solution which you had there. Basically, your whole service and applications integrated to each with each other. It can detect all those things, whatever is running, whatever apps are there, and migrate that to Microsoft Azure. So the next is we'll go to describe consumption based model. Yeah, so I should also come into IaaS, PaaS, SaaS. Yeah. So about the shared responsibility model, which we just uh, were discussing about. So there's something called as SaaS, PaaS, and IaaS. So SaaS stands for software as a service. Uh, PaaS stands for platform as a service, and IaaS stands for infrastructure as a service. I think someone's mic is on. Can you please mute it? Thank you. Yeah. So when I'm on a private cloud on that is on premises, then I'm responsible for absolutely everything. The data center, networking, hosting, then the operating system, network controls, applications, identity, and directory infrastructure. Basically, this particular employee has this much access on this particular service or PC. That is identity and directory infrastructure, accounts and identities again, then devices, then basically again the last thing is data. So when I am on premise, if I have a public private cloud, then I am responsible for the data that data center's security. I need to have walls, then certain external security measures, barbed wires with electricity or not, watchmen, guards, etc., etc. Security surveillance cameras, then physical networking, actually going to each places and rooms, connecting Ethernet wires and fiber optic cables to each other. Operating systems, the racks, everything. I'm responsible when I have all of that on premises, basically on my own private cloud. When I have this on, uh, when I'm using this as an infrastructure as a service, then the responsibility is a little bit of responsibilities moved on to Azure's part. So when I have infrastructure as a service, at that time I'm only responsible for the operating system till the data that is towards the top. I'm not responsible of the physical hardware and managing updating the physical hardware. So can someone give me an example of an infrastructure as a solutions, uh, an example of IaaS, infrastructure as a solution? Okay, did you even understand this, or I'm just keeping on talking and talking, just uh, spouting things at you, and things are going over your head. Hello, can someone give me an example of IaaS, infrastructure as a service?
Smartwatches.
Can you repeat? Can you please repeat? I didn't hear that
Smartwatches.
quite well.
Smartwatches. AWS.
AWS is a cloud in itself. Services under AWS can be identified as IaaS, infrastructure as a service, but which particular service? It is virtual machines, because in virtual machines I'm responsible for the operating system, data, uh, hosting applications and other stuff, networking and all, security too, but I'm not responsible for the hardware. That is infrastructure as a service. So when we talk about platform as a service, what could be an example? I'm not responsible for the operating system. I'm partly responsible for networking, partly for the application, or might fully be, little bit about security, and fully responsible for my data. What
Okay.
example could be for this? If you're not, if you guys are not comfortable with talking, you can also put that in the chat. What could
Gmail.
be a possible? Gmail. Actually, Gmail is a SAS. Gmail is a software as a solution. Can you think of something which comes under platform as a service?
GitHub.
GitHub, yes. Actually, GitHub also comes under software as a service, but in some way, when we want to host things on GitHub, then it might partly come under PAS. But what could be a very clear example of platform as a service? Has anyone ever used Nginx or Windows IIS to host their websites? All right. So when we want to host something on, on our own machines, then there is particular software which can help us in hosting things. Within Windows, it is called as Windows IIS, which is nothing but Internet Information Services (IIS). So you can create websites here and host it locally, and open the ports to some. Basically, you have a public IP, and you can open a particular port on your own PC. Then people can access that website on your public IP through that port, because basically your public IP is nothing but your PC's address. So when that address is contacted on that particular port, and you have that website exposed on that port, so at that time your websites open up to the other server, basically the user. So whenever you're going on to google.com, so what happens first is basically it searches for that name google.com. Google.com is nothing but a domain name. So first what happens is there is a DNS lookup. Your domain name, that google.com, is being checked on other servers, on your internet service providers list and other servers as well, which your internet service provider is connected to. So then they'll finally find a particular server which responds as the owner of the .com domain. .com, we write google.com, microsoft.com. So com is the main domain, then google is a subdomain under com, that is google.com. Then com actually basically google has uh, hired, not hired, basically rented that subdomain google from the domain owner or domain owner PC or server called as com. So when we search google.com, it goes to com, that basically com, and it tells us the IP address for Google, which Google has registered with com. So that is how things go around. Basically, when we type in google.com in our search bar, it searches for that com server owner, domain owner, which gives us the IP address of Google, and we contact that IP address, and networking packets of what or whatever we are asking. So basically, when I'm writing, I'll just show you here. So for example, I have a website here. So this is another, basically a website which I hosted on cloud. Basically, I created my own software as a service solution. So you guys might have used Google Drive and OneDrive. So I tried to create a very compact version of that, just to see and learn how these storage solutions in cloud work. So I've hosted that locally on my own PC. So this is the website. This is built and compiled using built using .NET, ASP.NET, and compiled using Visual Studio 2019 Community. So again, this was hosted on this particular hosting service called as Windows IIS. Similarly, for Linux, there is a service called as uh, Nginx. So in this case, when we're talking about platform as a service, when I'm trying to host something on IIS or Nginx, I'm not responsible. I'm not responsible for the operating system and the hardware. So when I was hosting a website on IIS, was I responsible of doing anything on Windows? Did I do anything on Windows? I didn't do anything on Windows. I simply opened that IIS thing and provided it with my own website. But I was partly responsible for the networks, because my application itself, it could connect to other things, and I might have to create some firewall rules or delete some firewall rules for my website to work properly. Say for example, it wants by default some export. Basically there are 16 sorry, basically 2 to the power 16. It comes out as 65534 or 5 something, or 6, yeah, 6 5. You get it, basically 65,000 something. Those many ports are there available on each IP address on your PC. So these are nothing but virtual ports. So basically, when I want that particular IP to access a particular port, and I want my application to do that, to access a particular IP on a particular port from my PC, then I might need to open or close some port on my own PC, or uh, basically to change some firewall rules. So I might be responsible for some network controls and then the application. Actually, I'm sorry because this has gone above 7. I'll take 15 minutes more because up till now it was only introduction to Azure, and now things will really spice up about cloud computing and different services Azure gives you. So up till now it was only in virtualization how these things work. So I'm sorry, I'm taking 15 minutes more. If anyone is against it, you can leave. The session is being recorded. If you want, you can listen to it later. But since I have already certified this examiner, I have been certified. I have read and learned all this, so I know that this is only getting more interesting from this point. Up till now, the basics part would have got you bored in some way, and it's only me talking. And also, like you to ask questions in between if you're not understanding things. Yeah, so anyway, then this is a platform as a service. I am responsible for the application, writing the code, then providing certain people certain access. For example, if I want to do something, my app is there, it wants to do something, and uh, say for example, I'm doing some processing, and once that processing is done, I want to send someone an email that okay, I want to run a machine learning or deep learning model. I want to train it, and once my training is done, I want my app to notify me that okay, this is done, come up and check the results. So I'm responsible for uh, giving my account the access to a Gmail or other email client, so that it can talk to basically it can send emails. So that is where identity and directory infrastructure comes in. Here's just a vague example. When we are talking about organizations, there's something called as your active directory services. Basically, in your own PC also, you might have different users. For example, in my PC, there is the administrator, and then there is me, Rahul, which is the user. So similarly, in organizations, there are many users with different types of access. So if you want your application to give someone some certain access, so it depends if you want to do that or you're not, or you don't want to do that. So it comes under PaaS, hosting things, that is Nginx and Windows IIS. Then within platform as a service and infrastructure as a service comes container as a service. Basically, that Docker which I told and showed you before, that comes in between all these both of these things, which is a different service in itself, which is called as container as a service, CaaS. So next we go to software as a service. Here you gave me an example which was correct. GitHub is software as a service. I'm only responsible for my data, account identities, and uh, the code which I am hosting. Apart from that, I'm not responsible for other things. Also, Gmail is an example of SaaS, because when I'm doing something on Gmail, then I'm only inputting my data. I'm responsible for the data. I'm inputting who I want to send that and what I want to send him, and mostly that's it. So the data is the thing, information and data is what I'm responsible for. So this is how within Azure the responsibility goes on. So for example, something happens, for example, security or something happens within Azure, and the security exploit was in a platform as a service. In a platform as a service, there was a security exploit somewhere within the information and data thing. Basically, you expose that data to people for them to steal it from you. So at this particular point, you will be responsible for your own data loss. But if there is something within Azure, like for example, someone uh, hacks the OS or the network, somehow someone enters the physical data center in Azure and connects bad USB, which is also called as a rubber ducky. Has anyone of you heard rubber ducky? Bad USB. I have a nice thing to show you. I created one. I think it might also lighten your mood a bit. So basically, this is a little bit into cybersecurity, but it'll be fun to watch. Basically, this is my Arduino Uno, a microcontroller, which I burnt the microcontroller in such a way, i- uh, in a way that when I connect it to my computer will recognize it as a keyboard rather than a microcontroller or a USB device. So what I did was I wrote some malicious code in here. Basically, whenever I connect it, so it should start my browser and go on to a particular video and then show a particular thing using activate a PowerShell script and show that okay, you have been hacked. This is a PowerShell command, and it says here show you have been hacked. So anyways, so this is just a little demo. When I connect it, it should detect it as a keyboard. I'm connecting it now. It's better if I show it in full screen. Yeah. So it opened the Windows menu thing. It searched for a website and it started this video. So yeah. So if someone within entered maliciously into an Azure data center and connected this sort of a bad USB in something, and it read all of your data, in such a case, Azure will be responsible for uh, your data loss. So Azure will have to compensate you rather than you losing your data of your own mistake. So that is how responsibility works in Azure. Then the next part is cloud models. I think we have done this. What was cloud models? Private, public. Okay, this is done. Consumption based model. Okay. So within Azure, the benefit in some way is that uh, no upfront costs, because if I want to have a virtual machine now, I'll just log in into Azure and show you thing. So for example, so this might also be a demo of how to create a virtual machine. So I'm just showing you how it is, how easy it is to create a virtual machine on Azure versus how tough it is and lengthy it is to create the same thing on your own computer. So this virtual machine will be in this particular region, East US. So you see there are so many regions in Azure. So you can have your virtual machine anywhere here. So basically, whatever your user base is nearest to, you will create your resources there so that you get the lowest latency uh, to your users. Then we can also select the images. So there are pre-built images within Azure, and there are the list is huge of how many images are there. So just within Windows 10, there are so many things. See, Windows 10 Enterprise, multi-session, and blah 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 blah. So many Pro. Then Ubuntu, within Ubuntu, there are again Gen 1, Gen 2, and ARM 64. So these are different architectures of hardware for which these machines are allocated. So for example, now I want what I want here is say an Ubuntu server. Are you guys familiar with Linux?
Yes.
So I can also have this NVIDIA V4 vCPUs. So basically, if I create this virtual machine, it will come with a GPU also. But just for the sake of showing, I'll take a normal thing. 2 cores, 8 GB RAM. Then I'll write a password. My user as user 1234. So you enter your password. So you can use this in two ways. Either you have a password or you use a SSH key. So I'll try to enter using a key because an SSH key would. I think that this is more of a secure way for me to uh, connect to a machine because an SSH key is normally a 2048 character long randomized key which is used to connect to your virtual machine using the SSH protocol, which is nothing but secure shell. And I can also select which ports are to be created, basically not created but opened by default. I'm saying to allow selected ports, which is 80 for HTTP, 443 for HTTPS, and SSH for 22 for SSH. Then say for example, I want SSD or HDD. As you know, HDD is slower than SSD. So within SSDs also we have different types and tiers. A standard one and a premium one. Premium is faster than the standard one, obviously. So we'll keep this premium. If you want, you can also attach new disks. Basically, say for example, by default, I don't have enough memory, or I somehow or the other ran out of memory. I can redeploy my virtual machine, or I can just connect another disk, SSD disk, to my machine, which will add more memory to it. And these are the tiers on which we can do pre-decided tiers. We can also have custom sizes. For example, alright, so this is the maximum limit, 32767, and within that, for example, if I want just 25 GB, then I can have that custom amount instead of getting a bigger option that is 32. So I'm not adding one right now because just for demonstration purposes. The networking, I can have certain ports opened for me. Is again this RDP. This is a remote desktop protocol. You guys might have used TeamViewer or any desk. That is an RDP application, a remote desktop protocol. Basically, you can connect to other PCs remotely. Being at my own PC at home, I can connect to any PC in the whole world if they have this port open, and I know the user name and password to their PC. So that is why by default, commercial and enterprise level services being hosted on whatever servers have these ports off by default. then we can select that when I want to delete this machine, you also delete the public IP for me, because when this machine will be created, it will also be assigned an public IP. A load balancer that can place this virtual machine in backend. Okay, what a load balancer is will come on later. Don't want to. I'm already been being bombarding you with information, so guys might get too much confused if I keep telling you new concepts. But we'll come to it later. So basically, we just select what we want, and we simply then now we are validating, and it is telling me that this will be the cost of the machine. So how cheap is this? Just see of this. How cheap is this? 7.5 Indian rupees per hour. If you convert that to dollars, 7.5, about 9 cents. Did I need to buy the hardware for this? Did I need any other expenses? I am just paying 7.5 rupees, that is about 9 cents for an hour, to use 2 cores and 8 GB RAM. By default, we have normally we have an i5 processor. Most of the people do have an i5 processor. So it has, I think, 4 or 6 virtual CPUs and an 8 GB memory. So let's see what is the price for this one. 4 CPUs and 16 GB memory. About 18 cents. So that is how cheap it is to create a virtual machine. So here comes the part: download private key and create resource. So I'm doing it with a SSH key rather than username and password. And you can also see how fast the virtual machine will create as compared to when you try to do it on your own hypervisor. So now it is being deployed. Meanwhile, if anyone has any doubts, you can ask if there are particular concepts that you didn't understand, because right up till now that was more theory. From now it will be more practical as well as theory. When I'm telling about virtual machines, load balancers and things, I'll also be demonstrating that. And if possible, I'd also like you guys to log into Azure and do the same. So if you are encountering any error, then we can solve it at that moment itself. It takes a minute or two for a virtual machine to be created. And we can also give it init scripts, initialization scripts. So basically, when my machine is being created, so say for example, there's a command called as sudo apt sudo apt update and sudo apt install upgrade. So what this does is it updates your uh, Ubuntu OS with all the repositories that it needs to contact different servers to install software packages and things. And other is to update your OS and other components itself. that is sudo apt install upgrade. So instead of going to the shell, opening it and writing these commands there, you could just write that in a box when when we are creating the virtual machine. So when the virtual machine is being created, when it is just created, it simply runs that script automatically for you. So it might not be just this, it might be other things also. For example, I want say Python installed when I open this machine. So by default Python is there in Ubuntu, but still, for example, if there is it may not be there in some other uh, OS, then we can give a particular command to install Python and we can connect to it. So here, if you see, if you have a Mac, then chmod is nothing but it gives you permission to use this key. That is why this command is there if you have a Mac. If you have a Windows, then simply use this command. So this is the public IP of my Ubuntu virtual machine that I just created. This is the public IP and this is my username. So I want to log into this using my private key. So right now my private key I installed on my downloads folder. I can simply go here and type cmd. So my command prompts open with this particular path. So I can simply go and dump this command and give the name to the key, which I named as my key 2442.pem. Yes. User 1234. Okay. This is my username 123 user 1234 at. So it is asking me to recognize this using the key fingerprint. So yes, and I'm logged in. cd/ls. So this is the Linux system Ubuntu. So I can say which commands I was telling, I was talking about earlier. Sudo apt all. See why this didn't happen, because I didn't refresh those repositories. Sudo apt-get update. So these are all these repositories from which it can download all the softwares and packages needed. So once the repositories were updated, now we can install things. We have used Linux, then this command normally works. I am not sure why this is not working. So after install upgrade. So I created a file hello. So basically this is how you create a virtual machine, and simply if you want to delete it you can first of all log out, go to Azure, open our virtual machine, stop it from here, and then delete. So it won't take a lot of time for this to delete. Again, 1 to 2 minutes. This will be deleted. So since I just showed you, it just costs 15 rupees. That is about 18 cents for an hour to use a virtual machine. It is you don't need to pay for any upfront costs. You only pay uh, when you use this. Don't need to buy the hardware and infrastructure. Don't need to manage those things. The ability to pay for more resources when they are needed. So basically, again, yes, you can create as many virtual machines as you want. Ability to stop paying for resources when they are no longer needed. So when you have when there is a private cloud, when you have things on your own premises, at that particular time, those resources, if you don't want them, if you don't want a particular app that is running on your system. So for example, you're deprecating an app, you're stopping the app, and now that hardware which was allocated to it is of no use to you, but you still need the you cannot just go away and sell that hardware or throw that hardware. And even if you sell it, it won't fetch you as much as for what it came for, how much you buy it for. So obviously when you're using public cloud you are at an advantage, but again you are at a loss in a case for when we can say about banks. It is very necessary for them to own the area where their data is being stored. Then again compare cloud pricing models. So basically we plan and manage our own operating costs when we are in cloud. We can run our infrastructure more efficiently. It is basically up to me how I plan and manage my stuff within cloud, and how I want to run my infrastructure in a more efficient manner. For example, on when it is on my own private data center, I had two machines which were say running a website of mine, and that website was say for example, when I uploaded something there, I uploaded a PDF file there, and it compresses it, for example. So on uploading, what I want it to do is process the PDF, compress it, and make me download it. Right. So basically, my computation is only when I'm uploading. So throughout the day, keeping the virtual machine on or keeping my server on, it is just costing me more electricity and managing things. And even if I have this on cloud, for the time the virtual machine is on, I have to pay for it. So for example, when I only have when something is being uploaded, it is making me pay more of what I'm actually using. So what I could do is I could use a serverless application here, so which I told you before, as your functions, this as your functions. So basically you don't need any container, you don't need any virtual machine. You just put your code in there. You just put a trigger point that how this is to trigger. Once it triggers, that function will do that process in whatever language you want. After that being done, it will show that output on whatever endpoint, on whatever website or path that you want. So you will only be using the function when it is in need. So that is how you will also save on your virtual machine costs. So again, running your infrastructure more efficiently, it is totally up to you how you run it and how efficient you make it to cut down your costs and provide the best, uh, as good of a service as you can. Then scale up your business whenever needed. So whenever our demand rises, we can scale up our business. For example, I have two virtual machines as of now, and I'm seeing that okay, our website is hitting more people than usual during say Christmas. So what we want is we want to increase our virtual machine so no one gets a DDoS type of reply that basically the server the request is doing this buffering thing, going round and round and round, and then the web page shows out after 10 seconds or 12 seconds, or sometimes it says that request error or 404 something. Not 404, basically request error or timed out. So you need to scale up. That can be done on Azure. So what you can do to scale up is we use load balancers, which I talked about before. So when you're talking about load balancers, what load balancers are, it is exactly as what its name suggests. Load balancers. It balances the load. So yeah, uh, I have a virtual machine here, VM1. I have another virtual machine, VM2, and now I have a load balancer, LB. So say this is the internet. I'm bad at drawing. So requests come in and hit this load balancer's public IP. What this will do for us is it will equally divide all these requests and send half this way and half this way. Also, this is not only half. We can also adjust the ratio. For example, we want this to have 30% of the request and we want this to have 70% of the request. We can do so by configuring this load balancer. This is what a load balancer does. So again, scale up as your business needs change. Then there is this knowledge check, a quick quiz. Can you guys tell me the answers? What is cloud computing?
Delivering of computing
First
services.
off,
Okay, delivery of computing services over the internet. That is correct. Which cloud model uses data centers focused on providing cloud services to anyone that wants them, and some data centers that are focused on a single customer? What would be answer? What would the answer for this be? A particular cloud model. There were three models that we talked about: public, hybrid, multi, and also private. So which one in this uses some data centers focused on providing cloud services to anyone that wants them, anyone, and some data centers that are focused on a single customer? So there are some data centers in a cloud model which are providing services to all, regardless of they being whoever they are. and particular service and a particular center within that cloud model uh, providing cloud services only to one customer. What would that be?
Hybrid. Hybrid.
Yes, correct. Hybrid. According to shared responsibility model, which cloud service type places the most responsibility on the customer? So, in which model is the responsibility the most on the customer? You can
Infrastructure as
say.
a service.
Infrastructure.
Yes. Yes. So, this was one of these modules. Benefits of using cloud service. I think I already discussed these. Oh, we didn't discuss these. Okay, do you guys want me to discuss this quickly, or you'll do this tomorrow? These are also nice concepts. I think I've talked about I've talked about this a little bit, but not in as much detail as it is given in here. I think it would take only 5 minutes to talk on all these concepts. You can just tell me to continue or stop, because it's already been 2 hours. Hello. Okay, you raised your hand, but what does that mean? Yes or no? You can type it in
Each
the chat box. Can you please repeat? I didn't hear you quite well.
each chat disable.
I don't think it is disabled. Chat. No, it is on. You guys have raised hands, but what does it mean? Yes or no? Okay, since I'm in the mood to explain, I'll take that as a yes. Yeah, so anyway, what is high availability? High availability means when you're deploying an application on service, basically a service is being deployed to some cloud or some infrastructure facility. When something goes down, an error occurs, for example, a whole data center goes down, and your services are distributed between data centers, and one data center goes down in itself, but you are still able to provide service. So basically, a concept of SLA comes in, service level agreement. When we are providing a service to people, a service from people, there is an agreement that we sign, which is called as a service availability guarantee, or service level agreement. So basically, when we are creating a virtual machine on Azure, by default, we will get 95% uptime. Basically, about 95% of the time, the virtual machines are guaranteed to be on. It won't go off. That is what Azure guarantees. That even if the disaster hits an Azure data center, your services would be on 95% of the time. So when we're talking about high availability, if anything is to happen, or any process shuts down or a server shuts down, your service is still available to your your user base and your customers. That is high availability. That means that highly available. My service is very highly available to its customers. That is high availability. So this high availability can be architected by a custom means or pre pre models, pre-created models by people of how you can achieve high availability. But actually it only depends upon your use case and how much high availability you want to give to your users, how much your agreement is, and how much you guarantee to your users. So within this also there are different things. There is SLO, SLA, and SLI. First of all is the service level agreement, which is the guarantee that I tell my customer that this much percent of the time you are going to get my service for sure. If you don't get that service, then I am I am responsible for that problem that you had, and I will have to compensate for it. That I will have to pay you something because I failed my agreement. I failed to guarantee that much uptime of my service. That was SLA. Then the next thing is SLO, service level objective. So from what the guarantee we give to our customer, a little bit higher guarantee we keep for ourselves. That is this is our objective. For example, if I tell a customer that my service is will be available to you 95% of the time, basically 95% of the time my services will be available to you. So I will keep my own objective as 97% or 98%, so that I am sure to to be on a safer side than paying that compensation. If I keep an 98% uh, objective and I am constantly trying for that objective, then there is a very less chance that I will not be able to even give the 95% guarantee that I given to my customer. So that is service level objective that I decide for my own self, that I am not to come down from this point, to be on the safer side rather than paying compensation to my customers. Then there is service level indicator. Service level indicator is nothing but an constant check of how much my services are actually giving. So I'm constantly monitoring. Has anyone used ping, ping? Excuse me. Has anyone used ping, ping, to check which PCs are there on the network?
No.
So basically, say for example, there is a PC which needs to be on my. Yeah, okay. Let's take an easier example. And there are two computers connected to my router. So what I do is I'm telling ping and the IP of my router. So what this does is basically it connects to my router, and it tells him that okay, you just send a packet, basically a request to this other PC which has this IP, and if that that request reaches that PC, then that PC will tell okay, yes, I am here, I am available. This is called an ICMP packet. This is basically used to check if the network is working properly, that my requests are able to reach to the other PC or whatever server I want it to reach to. So that is what ping is used for. So here when we are talking about service level indicator, a similar software is which constantly monitors how much my service is able to. So for how much time was my service on, for what particular specifications my service was working, was all those my Was my virtual machine working at this much power, at 90% compute power, at 60% power, on 50% power, on 10% power, whatever. To monitor these things so that we can it can help us to achieve our SLO, service level objective. Then there is scalability. Scalability I already explained. This is again into two types. When we want to expand our infrastructure so we can accommodate our service for more users, there is vertical scaling and there is horizontal scaling. So when we talk about vertical scaling, this was my virtual machine, uh, two virtual cores, 4 GB RAM. So when we vertically scale this, vertical scaling means this hardware inside this machine will be increased to a bigger virtual machine. So at the end, I will only have one virtual machine. This will just be converted to this big virtual machine. Say for example, this will be a VM with uh, 8 virtual cores and 32 GB RAM. So this is virtual scaling. This scaling up to this virtual machine, a bigger virtual machine, where only the hardware components increase. Say earlier this machine only had one Ethernet port, which is called as an NIC card, and now after scaling this up, now this has say three Ethernet ports. That is three NIC cards. So basically, the network capability of this machine also increased. That is called virtual scaling. Scaling up virtually, and this is horizontal scaling. I have this small machine, which is a VM, 2 V-core, 2 GB RAM. So say for example, I want to scale horizontally. So instead of adding all these components to a single virtual machine and having only one big virtual machine, what I can do is I can add small virtual machines according to my requirement. Like now, for example, here this machine can handle 100 users. When I see it, my user count coming, my traffic incoming to my machine nearby to 100, I will just add one more machine to this machine, and add one load balancer here. So when I see this going toward uh, near to 200, I will add one more. Similarly, I will keep adding until I have this properly. I can meet my user demand. So this is called as scaling up. This one is vertically, this one is horizontally. So this was scaling up. We are increasing to accommodate according to our users. Now there is scaling down. We are decreasing to cut down on costs. Now, for example, here I was having say nearby 500 users. That is why I had 5 virtual machines here. But now this count is going down and it is nearby a 350 now. This has become nearby 350 now. So what we will do now is we'll cut down this machine. Similarly, now when this comes nearby 250 or 150, we will here 250, this one 150, and when it becomes near by 90 80, then we can only have one. And but this will remain the bare minimum because our application always needs to run. Similarly, for vertical downscaling, basically scaling out, like one was scaling up and scaling down. So scaling up was increasing, scaling down is coming down again. So I had this requirement, and again say my traffic decreased. Users are not as many users not attending the website. that can be easily accommodated by this machine. Not easily, basically according to this capacity. Yeah. So when I have extra capacity here which is not being used, this is just a waste of money. So what it will do, I'll scale this down vertically back to this machine or some other variant which is smaller than this one according to my requirement. But what actually we use in IT industry is we use horizontal downscaling and upscaling. This one. Reason to use this more is because when we are scaling this up, when we are adding one machine to this original machine was always there. That is why our application never went down. Our application was always up, hence we were meeting the SLO requirements. Uptime was being achieved. But when we are creating this machine, this original machine will go and shut down for 2-3 minutes, and everything will be provisioned into this bigger machine, and then this one will boot up. So there will be this external, this extra 3 minutes or 2 minutes, 5 minutes of downtime which will affect our SLO. That was vertical and horizontal downscaling. Then there is reliability. Reliability is the ability of system to continue to function. It's also one of the pillars of Microsoft Azure well-architected framework. So about reliability, how is Microsoft Azure reliable? How can we make our systems reliable? Say for example, we had our infrastructure in Azure. We have our infrastructure in Azure. This was my machine. These were my two machines which were hosting some website in one data center. So this is the data center. So this whole data center for some reason went down, and what I had done is I had backed up both of these virtual machines. I had backed up both of these virtual machines somewhere, and the data had also been backed up. So what happened, as soon as these went down, so this going down was detected by I was running a code on Azure, which is also service called as Azure Monitor. So when this went down, and we also detected that the data center was down. So what we did was, there was another data center near this one. We just created the same thing in the new data center. So that is how we achieve reliability. So again, they're telling the same thing. With this global scale, even if one region has catastrophic event, other regions are still up and running. You can design your applications to automatically take advantage of this increased reliability. So we can design our applications to take advantage of the situation. If something goes down in one data center, we can replicate the same thing in other data centers. And as soon as the old data center again comes back up, we can deprovision or delete those things which were there in other data center that we created, and again provision them back here. And predictability in the cloud lets you move forward with confidence, because we know when we were creating the Azure virtual machine, it told us that it will cost us about 15 rupees. It was predicted that was amount would be there. Even if the amount goes a little bit up and down, it won't affect that much. But that prediction of 15 rupees, that makes me confident. Okay, that these costs are very less. I can handle these costs easily. Predictability can be focused on performance predictability or cost predictability. So basically, cost predictability again this, and again performance predictability. When we are talking about an Azure virtual machine, when we create a virtual machine, Azure tells us that your machine will be 95% of the time on. It will not be shut down by us for maintenance and those things. So again, performance predictability. Both cost and performance predictability are heavily influenced by Microsoft Azure well-architected framework. Then again, there is a little bit about how performance and cost will help us move forward with confidence. According to within performance, there are many concepts that come in, and I can just mention that, such as auto scaling. Basically, we can create our virtual machine in certain sets. We can create virtual machine sets. There is a service in Azure that whenever we are receiving so and so traffic, when it goes about this threshold, or my computation of my machine goes about this threshold, I want you to auto scale it. Create another virtual machine automatically with so and so things that I'm telling you, and load balance it for me. There is a load balancer connected to it. So when the machine is connected, by default the traffic gets divided into the both machines based on whatever ratio you want. Then since you created new machines, then if this old one goes down, you still have your one machine up. That is again high availability. So these are just some cloud concepts that support performance predictability. If you have sudden need for more resources, autoscaling can deploy additional resources to meet the demand. Again, if you suddenly if you are in need of more computation capability to serve your users, you can create more machines and again scale that back when your demand drops. When your traffic is heavily focused on one area, for example, you have your whole infrastructure. There is your one infrastructure, one service setup. Your one app setup is in UK, one is in UK, one is in UK, one is in US, one is in Australia, and one is in India. But you are seeing that okay, the India one is currently getting a lot of this traffic, rather than when my other things are there, my other demands are there, my other app infrastructure and setups are there. They're not getting as much traffic. So what you can do is you can attach these to a load balancer, and the free service, free capability that is currently just being you know just out there, not being used, costing you money. You can direct that traffic to those resources so that you can use them to the optimal uh, requirement of yours. Then again, cost predictability. You monitor resources to ensure that you are using them in the most efficient way. So basically, you are always monitoring your resource, and you can check, okay, these particular parts of my application are, I'm paying more for what I'm using. I'm paying for more than that I'm using. Yeah. So I'm now since you know that this particular app is being underutilized by me, hence you will move to an architecture which will cost you less. For example, you were using two virtual machines, and for example only one virtual machine was being used even after scaling down, and even that virtual machine was only being used, for example, say 30 or 40%. So now what you would think to go for a better way would be to go with serverless architecture that I speak of before, only triggering things when in basically only computation when in need, or going to a container. Container are lightweight and they handle less as what uh, virtual machine can handle. So again, you pay less for containers, and you can scale them up whenever you need to. So there is this total cost of ownership calculator, which helps you get an estimate of what will be your total spend in cloud. I'll also show you this. So a little bit ago, I was there in a nano degree by Udacity, and there I had this project to calculate the total cost of what I will be facing if I migrate to Azure. So I had a scenario where I was working for a company. Within that, that test, there was a scenario was given to me that I was working for a particular company, and what they wanted me, this was the project. So helping company go through migration from on-premise to Azure cloud. So what they wanted me was to access on-prem infrastructure and services. That first I find out what is there on my current private cloud, my own company's cloud, and getting cost estimates. So basically what I'm paying for the current thing that I have, including paying basically the hardware cost, managing cost, IT cost, maintenance cost, networking and power. Then again replicating infrastructure and services. Then how do I replicate these things into cloud, or basically take backups and recovery, also on premise and on cloud. So the second project was cost optimization and monitoring. So here I was only given a task of understanding about the costs and how do I monitor my things on cloud. So first I access the on-prem environment, basically the on-premises, what I have on premises, and I create a total cost of ownership report. So this calculator which I talked about before, I'll just show you this. Project 2, yes. Yeah, so this was my current the company I was working for in that scenario. This was the current infrastructure that they were having. So they had this server, so and so thing. They had 10 servers, processes that they were running on per each server. Then there were cores that were being used for process, the total RAM that they were having, and optimized by CPU. Basically, they were the machines that they were using were more CPU optimized. Basically, they will do computation better. There are some machines in Azure that do storage better, some do queries better, some do networking better, some do computation better. So based on whatever your need is, you can optimize it for your use case. Then there was this application here. This was purpose Windows and Linux server that they wanted. The other was a web application that they had hosted, and the final was a database server. So after getting a good estimate of what they had, again this storage, their storage, what they were using for backup and things. So my first task was to access the on-premise environment. They wanted me to test how much am I paying this uh, on my own data center versus how much I am going to pay on Azure. So first I tested the environment. So basically there were 10 there were 10 virtual machines. Then there were 3 web applications, 3 database servers, and a storage device. So I went on to that calculator and I put in that okay, this is this Windows Linux server, Windows or Linux server, whatever it is there. Then there 10 VMs were there. The virtualization was done on using Hyper-V. There were 16 cores, 250 GB RAM, as told on in the above specifications when mentioned. Then there was a web app. Web app had 3 VMs, 8 cores, 64 virtual, 64 RAM. Then again, this database server, whatever the things were, I put in the proper specifications that were needed, and also the storage. So how much networking that they were using, as they had described. So based on that, I got an estimate of how much they will be paying on Azure versus how much they will be paying if they buy and manage it on by themselves using this calculator. So when you do it on Azure, this was the yellow line, and when you were doing it you by yourself, then this was the blue line was this. So within 5 years you could see how much you were saving. Within 1 year it was not as much as you could see the difference, but again when you see within 2 years the difference is quite large, and finally after 5 years you are saving on a lot of money. So total on premises over 5 years, the total cost when you are doing it yourself was about this much, where this was the the division on how things were going to cost you. 93% was going to be costed to you on compute, basically buying servers, and 2% on data center, basically owning a place, having guards, CCTV cameras, security, blah blah. Then networking, storage devices, then IT labor who will be doing the maintenance and checking on things. And if you do this on Azure, the IT labor will increase a little bit, because you need to constantly monitor and check on the things on cloud. 91% compute was there, but compute here in case does not have any hardware costs, and your networking and data center cost totally dropped, which were here. And you could see here that how many dollars that they have saved just by doing this in cloud. This is a total comparison of how things are going to cost you. Hardware within when I talked about compute, this comes in between electricity, software, and hardware. So when we count that in, this will be counted as the compute one. So basically, hardware buying things still cost you a lot. Software not as much. Electricity comparable, not comparable. Data center, this cost will totally drop, and this cost will totally drop. Hence, you see that big spike here, because you need to constantly buy and manage and maintain your hardware when you're doing it on your own, whereas on Azure you're only paying for what you're using. So here it is just the computation cost, that is the rent of the virtual machine, a little bit of storage and IT labor. And here you can see when you're doing it and on Azure, you pay for the virtual machine, data center no cost, networking little bit, storage and IT labor, basically your administrators, network checkers, etc. Your IT labor was way more, because they actually also needed staff for the hardware. Storage was less, all right. Networking was more, because you have to do it from scratch, getting connecting to uh, basically there's a bigger network provider that you will pay for connecting you to the internet, and that networking in your environment also you have to manage on your own. Cost of the cables, maintenance of the cables, etc. A data center owning a place and having it secure, then database, virtualization, and the most was this hardware. This cost totally is cut down because you are using things on cloud. So this is a comparison of how on-premise cost versus on Azure cost on cloud. So the hardware costs are the cost of physical servers which need to be replaced and maintained from time to time with the needs of organization. Hardware costs in Azure are none, because Azure is providing services to you and you are not managing any hardware. Simply use what you want. Here you cannot scale up as your requirement. If you want to scale up, you need to buy new hardware. But on Azure, you can scale up. You just need to rent a new virtual machine. The software cost may be OS licenses, which might as uh, such as the Windows key or other licenses, Windows Pro OS, etc. Each license can be used by only one machine on premises. So, for example, if you have these license keys and you are migrating to cloud, another benefit is that if you have keys on your on premises, you can use those same keys on your cloud environment. This won't cost you more. You don't need to buy more keys when you are renting a Windows virtual machine. So Windows and SQL images does not require licensing on Azure by default, but there is I'm sorry, does require, not does not. It did they if you're going to buy a virtual machine from uh, a blank position that you don't have anything, you're just creating a virtual machine from scratch. By default, the SQL image and the Windows SQL server and normal Windows Enterprise server, those images will cost you a price for this license. But but still with the license also, you saw that 7.5 rupees, 15 rupees, 18 cents. That is not as much. But we can see that over time that may pile up. But still, but there is a hybrid benefit here. The hybrid benefit was if you have those licenses on your premises, you can port those licenses here and not pay additional pay for licensing. Electricity cost of the server computing, which would be a lot, as hard would not as all work would be done on on-prem servers. Yeah, since you're going to do all computational stuff on your PC, on your private data center, then you will be responsible for all that electricity cost. But here, electricity cost here are the PCs which use Azure resources. So computationally costs are generally just for networking. So there is not a whole infrastructure that you need to run just to run one virtual machine or things. But when you want to have one on just one virtual machine in your whole data center, you need to keep one whole rack on, or just one at least one server on. That server will eat more energy as compared to what one virtual machine will eat. Another the cost will be for networking. Basically, as a computational cost of sending commands and data to the cloud server. Also, Azure electricity cost on Azure are lower than general cost, as Azure data centers are also use green energy from power plants owned by Azure from Microsoft. So basically, when you compare energy created by these cloud giants versus energy you're buying from companies on a commercial base, so buying energy by Microsoft would be cheaper because they are using green energy, windmills, water turbines, dams, etc. Again, these are those things which we discussed earlier. So yeah, describe benefits of security and governance in cloud. Yeah, so as I said, there are some countries which there are some countries which have certain set of rules that are to be followed. For example, if I have something to be hosted in UK, then it should follow the norms of the UK government. So whatever cloud data center is there in UK, it will be by default following the norms of the UK government. So hence, when you will create some resource there, you will also by default be following their norms. So that is why this is the benefit of security and governance in the cloud. One of these things like set templates help ensure that all deployed resources meet corporate standards and government regulatory requirements. So when we are creating virtual machines, there are also some templates that are already available to us. I did not show this before, but on Azure, there are certain templates that are by default available to us. When I am to create a virtual machine, you can go here and you can go Azure virtual machine with preset configuration. So here you see there are some preset configurations for me to play with. Then again, more VMs and virtual solutions. Then you see there is a particular LAMP stack with Azure VM. It will set this all for you. Scalable WordPress using Azure VM. So basically, there are some many templates, not just this. If you go to Marketplace, there's Azure Marketplace. There's everything that is given. Now, for example, this I want this virtual machine, NVIDIA GPU optimized VMI. So this will be created according to industry standards, static web app. So there are many things that are already there. If I just go your VM, let's search this. As just Windows. So now there's a preset VM available for me just to click create and it will set all things for me. Just need to put in, username, password, a little bit of things that we want. For example, this port should be open. So these are preset things that are there already. Plus you can update all your deployed resources to new standards as standards change. So when we are talking about resources, for example, I'm using a platform as a service. At that time I'm not responsible for the operating system. Yeah, so keeping that operating system on which that platform or the service is already working in the back end is the responsibility of the cloud provider. So since they have to maintain on industry standards, hence that is why whenever then a security update is there, they will do it by default. Cloud-based auditing helps flag any resource that's out of compliance with your corporate standards and provides mitigation strategies. So there is also a helper called as your advisor, which you can use. So it will give you recommendations that okay, this thing is not properly utilized, this thing is not properly secure, this thing lacks this things lack this thing is being overly utilized, whatever. So it gives you advice and suggestions on things which can help you detect and run things more efficiently. On the security side, on the security side, you will find a cloud solution that matches your security needs. So definitely, I showed you where is it? Marketplace. So there are things for security here too. So we can always find things that will meet up to our requirements. If you want a maximum control of security, yeah. So basically, for example, when we're talking about a cloud solution which needs to match our security need. So say for example, I want a particular port open, say port 80 open by a virtual machine so that it can be contacted by users, and rest of the thing I want off. And I want that this should not communicate with any other thing in its network other than only one PC which is doing some processing. So that thing, whatever I'm telling you, this can be easily created in Azure just by using few clicks and typing, not even commands, just the addresses that you want to open and close. That is how easy it is to control networking in Azure. Actually, when I created a VM, I should have shown you that, but somehow or the other I forgot that. There is something called as a network security group and inbound and outbound rules which can help you do that in Azure. So we'll be coming on to that tomorrow or so. I think it might be tomorrow. Then again, management of cloud, automatic scale resource deployment based on need, deploy resources based on pre-configured template, which we talked about before, removing the need of manual configuration because they're already pre-configured. The monitoring of health of resources and automatically replace failing resources. As we said that there is as your monitor, we can properly monitor resources and see that okay, this is underutilized, and for example this virtual machine somehow or the other keeps on restarting for some reason. So I just what I'll do, I just create a delete this virtual machine and again redeploy a new virtual machine, so whatever error I may have done may be mitigated. Receive automatic alerts based on configured metrics so you are aware of performance in real time. So again, automatic alerts on some custom metrics that we have put in, that okay, whenever my computation goes this much, whenever my networking goes this much, whenever my usage goes this much, wherever my RAM goes this much, my GPU goes this much, I want you to alert me or notify me, do something. Basically anything can be done, anything can be set as a trigger, anything can be set as an actuation. So any trigger can do any action within cloud. It is very easy and you can create any of your solutions here. Management in the cloud speaks of how you are able to manage your cloud environment and resources. You can manage through a web portal, that is Azure web portal, obviously, which I showed you now. Command line interface, yeah, I forgot to show you this. So here you have Cloud Shell here on Azure. So when I create this, there is storage being mounted here, which will be connected to my Cloud Shell. So whatever I do here, I can this will be saved in my storage account, whatever thing is being showed here. So anything I do here will be saved in this storage account. I think it will take a minute to do this. So I almost done. This is bash. I'll also just show you these things just to be quick. Okay, for example, this is my personal portfolio website. This is the repository to this. So I'll copy this link and I'll go into Azure. And this was the Cloud Shell, which already has many things. For example, it might have, does this have Python? Yes, see, by default it has Python. Then there are many developer tools installed here already. Then there might be apt is not there. Okay, dpkg. Okay, so we are not allowed to download things here. But I think there git will be there. Yeah, git is there. So git clone. So I just cloned some code here. That's my repository, and you can go in here and see index.html, images, and this was the whole website. So let's just open this. I do have nano. Yes, control X. Nano index.html. This is the whole HTML code. So basically, all of the development work uh, that we need to do within Azure, some small changes that need to be done, or we need to create resources from Azure. Everything. Say for example, just go on to CD. Yes. So what I want to do here is, yeah. Say for example, AZ. So AZ is the command used to talk to Azure. So you see, now there are login extension. There are many things here which we could do. Now, for example, I'll just show you a command which can create a virtual machine. So now this particular thing can be used to create a resource group called as tutorial resources in East US region. Simply go here and I paste this command. It will do this for me. You can go into, I just created this for me. You can simply go into resource groups and here you can, let me refresh this. See, tutorial resources. Also, I'm sorry for the noise, but it will go in a while. There's a festival going on in our country. So, does anyone want to solve this? Which type of scaling involves adding or removing resources such as virtual machines or containers to meet demand?
Horizontal.
Let's check. So I don't think we can continue like this. So let's end it for you.